Hello my dear students. So welcome back to NEET World. So in this session we will be discussing chemical kinetics in continuation to the last discussion that we have completed till first order rate equation. Right now, I mean, how can we use integral rate equation for first order, zero order, and differential rate equations, and also graphical methods. Right now, so in numericals, I mean PYQs related to first order and zero order we have discussed. Right now, yeah. So in continuation to that, we will be discussing second order today. Second order reaction and how can we give integral equation for that. Differential equation and integral equation for second order reaction and numericals related to that question, topic. Okay. Now, if you are new to our channel, so first of all, I request you to click on the subscribe button, and also if you like the content, you can share with your friends at the ending of this session. Okay. So now see, you just give a try for all these questions. This was the questions that I have discussed in the previous sessions of chemical kinetics. This is the first question, and another question here we have. All these are the questions that I have discussed in the previous sessions. So give a try. If you are unable to do this, you can watch that previous sessions. It will be helpful for you. Okay. Next, these things. Okay. So today we will be discussing about. You can try this question also for first order reaction. Yesterday we have discussed in the last session. So now I will be discussing second order reaction. Second order reactions. So what happens? We know reactant, let us say A is a reactant converting into some products. Okay. So now rate of reaction depends upon the concentration of this reactant right now. So rate of this reaction proportional to concentration of A, and I am saying it is a second order which can be given from experimental data. So you can write that second order here. So concentration of A to the power 2. So 2 represents order of this reaction. Okay. So now I am removing this proportionality. I am writing K2. It means rate constant for this second order reaction into concentration of A to the power 2. Okay. So now what do we mean by rate? So rate is nothing but, how can we write this differential equation? See, change in concentration of A, dA by dt with respect to time. See, concentration of reactant decreases, product increases as time goes on. Right now, at the beginning we have only reactant concentration. As time goes on, like 10 seconds, 20 seconds, as time goes on, product formation takes place, therefore reactant concentration decreases. So it is decreasing now, so you write minus. So minus dA by dt represents what? Decrease in concentration of reactant for this particular reaction. Okay. So now rate is equals to minus dA by dt. This is equals to K2 into concentration of A to the power 2. So now from this equation I want to get an integral equation for this second order reaction. So how can I write? See here, differentiation of A, dA is there. So I can write 1 by A square dA. It means if like change in concentration of A. Okay. So now I am writing this dt this side and minus as it is. So K2 dt. Okay. So now try to integrate this equation. So I am applying integration to this on both sides. So like this. So initial concentration, for example, A converting into product, I am saying now at time 0 we have concentration of this A as A, let us say initial concentration. After some time t, what happens? Some of this reactant converts into product now. So there is some decrease in concentration of A, this reactant. That's why I am writing A minus X. So same amount will be converted into product. So X is the amount of product formed. It means same amount of same concentration of this reactant is decreased. Therefore I am writing A minus X. So A minus X is the concentration of A remaining after some time t. Okay. Now, so this I am applying integration on both sides. At a time t0, at initially, what is the reactant concentration? A. After some time t, what is the concentration of reactant? A minus X. So I am applying the limits also here. Okay. So now try to integrate this. What you are going to get? See, we know integration of x power n dx. If we have like this, how we are writing this? So x power n plus 1 by n plus 1 right now. So here also we have similar kind of things. See, I am writing minus a to a minus x. So I can write this 1 by A square as A power minus 2. Okay, concentration of A power minus 2. This is in the denominator, I can write in the numerator like this. So A power minus 2 dA, okay, equals to K2 0 to T, okay, dt. Okay, so now see, if I do x power n dx will be x power n plus 1 by n plus 1. So similarly you can apply here. So what you are going to get? It will be A power minus 2 plus 1 by minus 2 plus 1. So negative sign as it is I am writing here. Okay, so what are the limits? A here A minus x, here K2 into T. See, integration differentiation removed. So here T, here it is 0. So now try to apply this upper and lower limits into the equation. See, minus 2 plus 1, it will be minus 1 now. So minus 1 into minus, it will be plus. So just take A minus 1 here, A minus x by A, here K2 T. Apply upper limit, so T minus 0, it will be like this. So what about this? So it will be 1 by A minus x by A now. So we can write this as, just put this value in the place of A, that is what, applying upper limit minus lower limit. You will get 1 by A minus x minus 1 by A. Okay, this is upper limit, here we get, and we putting lower limit, you will get like this. This is equals to K2 T. Hope this is clear. All the steps are included very clearly and everything is clear, I hope. Next, from this if I want T of this particular reaction, time for this reaction, so 1 by K2 into 1 by A minus x into 1 minus A. This is how the integral rate equation you will get for second order reaction. Okay, so now what if I ask for T half, I mean time required for completion of half of this reaction. It means A is the initial concentration. So time required for half of this reaction means A should become A minus A by 2. It means A minus x will be equals to A by 2. Okay, so it means our x is A by 2, therefore you can say A minus x is also A by 2. So what happens here? T half equals to 1 by K2 into what I can place here for half life, I am saying half life of this reaction, half life. Okay, what happens here? 1 by A minus x should be A by 2. Okay, so A by 2. So I can write here 2 and here 1 by A. Okay, so from this T half equals to 1 by K2 into, so what you will going to get here? 1 by A. So this is what the final equation you got. What is T half of second order reaction? So that is just 1 by K2A. Okay, this is very important. Okay, in the first case, in case of zero order reaction, T half is directly proportional to A you got, and second for first order reaction T half is independent of initial concentration, and here T half is inversely proportional. T half is inversely proportional to concentration, initial concentration. This is important relation to be remembered for second order. Okay, so now instead of using always doing this integral equation, how can we generalize this equation, integral equation and differential this T half equation for nth order reaction? N can be anything like 1 like 2 3 4 5 like that, but not equals to 1. So now I am generalizing this for an nth order reaction. For an nth order reaction, how do you write this integral equation? See, first of all, having clarity over the formulas is very important. Okay, and doing the numericals is again one of the most important thing. In order to do numericals, you should have complete clarity over the topic first. That's why how integrated, differentiated or simplified all these things. Okay, now for an nth order reaction, what is the T, time required? How can you write? See, for second order reaction you have here 1 now. So for nth order reaction you will get n minus 1. Okay, just use this equation, n minus 1 into Kn 1 by A minus x. See here A minus x. For second order reaction, here I can put n minus 1. If n is 2, you are going to get something like this, and 1 by A power n minus 1. Okay, so this is the equation for any order reaction that n naught equals to 1, I can say. This is the very important thing you should remember. Okay, so now just put n equals to 2 here. So what you are going to get, t equals to n minus 1, that is 2 minus 1 is 1 into k2, okay, 1 by a minus x to the power 2 minus 1 is 1 and a power 2 minus 1 is again 1. See, same equation we got, just put n equals to 3, you are going to get for third order equation, like that. Everything you can able to derive using this particular relation. Very important relation this is. Okay, so now from this, if I ask you to do for t half, can you able to do this? Yes, you can able to do. Why? Because just a minus x you have to take it as how much? You have to take it as a by 2, because for t half means time required to convert concentration of reactant from a to a by 2. That's it now. So put that value. So t half equals to 1 by n minus 1 into k2. See, kn I am writing as it is. So here it should be half life now. T half means a minus x should become a by 2. So a by 2 power n minus 1 and here minus a power n minus 1. Okay, write as it is. So then next, how can you simplify this? T half equals to 1 by n minus 1 kn, and you can write this as a power n minus 1 2 power n minus 1, like this. Okay, and here a power n minus 1. See, denominator is same now. So you are going to get t half equals to 1 by n minus 1 into kn, here a power n minus 1 2 power n minus 1 minus 1. This is the t half of any nth order reaction, not for first order reaction. Okay, remember these two things. These are the generalized formulas, very important. Okay, yeah, you should remember. For example, if I ask for second order reaction, what you are going to get? T half of second order reaction equals to 2 minus 1 is 2, so k2. So here 2 minus 1 2 power 1 minus 1 by a power 2 minus 1. So what you are going to get? 2 minus 1 is 1. So 1 by k2 into a, that's it, t half. So same equation we got now here also. When we did for this, see, 1 by k2a, here also 1 by k2a. So these are the two important equations that should be remembered. Okay, now I am going to explain few questions related to this topic. Okay, so I hope you are clear with the questions, this one, formulas right now. So just tell me what is the answer for this question. So look at here, rate constant of a reaction is 2 into 10 power minus 2 and molarity inverse, second inverse. Calculate time required to decrease the concentration of reactant from here to here, from 0.5 to 0.25. How can you do this? First of all, identify which order reaction it is. They are saying rate constant k is given with this. So whenever they given k, so what is the units of rate constant for nth order reaction? You need to identify what order reaction it is so that you can easily answer this question. See, for an nth order reaction, the units of k will be equals to molarity power 1 minus n and time inverse. Okay, time let us say in seconds, second inverse. So second inverse will be fixed here. So molarity power minus n I have kept, 1 minus n I have kept. Okay, so what is the n value here? If we place, we are going to get this. If n value is equals to 2, we are going to get these units. It means what is the order of that reaction? Second order, because see, molarity they are saying mole per minus 1, like m power minus 1 is there now. So it means 1 minus 2 if I put second inverse. Okay, this will be like this. Okay, so what is our n value here? So it is 2. So it is a second order reaction, like this. By looking at the rate constant units, you can able to identify which order reaction it is. This is a primary step you need to remember. Okay, after this, for second order reaction, what is the equation we got? Integral equation 1 by t equals to 1 by k into 1 by a minus x in minus of 1 by a. Right now, so simplify this, try to simplify this. What you are going to get? 1 by k, I can write as a into a minus x as LCM here. So a minus of a minus x. like this. So here 1 by k, see minus a plus this I can remove, plus a minus a, and into x by a into a minus x, like this also you can take. Yeah, so look at the question what they have given. So t equals to 1 by k. K is how much? 2 into 10 power minus 2 is mentioned. Okay, and here x is how much? The concentration is 0.5 became from this 0.5 some x percentage, x is converted into product now. This is the reactant concentration, product concentration converts now as time goes on. So now this concentration becomes 0.25 and half of it converted into this much, like this. See, by looking at this, that is a scenario now. So x value is 0.25, okay, and here a value is 0.5 and this is 0.25. That done. So we are done with the substitution. So remove these two things. Yeah. Next what you are having? So 10 power minus 2 I can write 100. So 2 into 0.5 is nothing but 1 by 2. So you are going to get 100 seconds. What is the time required for conversion of 0.5 concentration to 0.25? 100 seconds. Hope this is clear how we have simplified this kind of numericals, right? Yeah. So if it is clear, just tell me in the chat box it is clear, sir. Yeah. Is there any other confusions from this? While substituting the values or understanding the question, any confusions are there? Feel free to write. Yes, yes. I am looking into the chat box. You can express your concerns. Clear, clear, clear. See, next thing is, I have one more question. Write this question. See, I am asking T half of the reaction. See, I am giving you T half or T 10%. T 10% of reaction is 20 minute. Then calculate T 90% for second order reaction. So these are the other model question that you can expect from this concept. So how can you do this? So look at here. What is the final derivation we got here? For a t equals 1 by k into x by a minus x into a, right now, a into a minus x, right now. So now how can you do this? See, they are saying t 10%, it means time required for completion of 10%. If it is 100, it is 0, reactant is converting into some product. So this is a is 100. So now time required for completion of 10%. It means from 100%, 10 is converted into this side. So here a minus x is how much? A is 100 and x is 90 and x is 10. Okay, so 10. So your remaining a minus x value is 90. So understanding this is also very, very important here. Okay, so now for t 10%, they are asking t 10% data is given, t 90% time they are asking. So t 10% means what I can write? T 10% equals to 1 by k into, so what is our x here? X is 10 and a is 100, okay, and a minus x is 90. Write that things here, and I am taking the ratio of this. For t 90 they are saying that t 90% will be here also 1 by k. Here x is how much? 90% completed now. So here 10% means you have taken 10. 90% means you take x value as 90, and here what you should take? A is 100. 100 minus like 100 minus x. X is 90 now. 100 minus 10 90 is 10 here. So put here. Okay. So try to simplify this. T 10% by T 90%. equals to this, you can remove. So here you have, see, I can remove, what I can remove, see, I am just simplifying it, 90 into this, you can write in the numerator, into 10 by 90. Hope this is clear up to here how I have written this. Yeah. So remove this 0, and next here these 2 zeros and 100. So you are remaining with 1 by 81. This is equals to T 10% by T 90%. T 10% is mentioned in the question as 20 minutes, right now. So take 20 minutes by T 90 minute, time required for T 90 percentage. Okay, so T 90 percentage is equals to 20 into 81. So how much it is? 2, 16 and 0. So this many minutes are required for completion of 90% of this reaction. Hope it is clear. Yes, these are the very important models that should be focused. They will ask either direct calculation of T using the integral equation, or they will ask us by giving some x% they will give, time required for x% completion they will give, and they will ask for time required for y% completion. Either they may ask in first order, 0 order, second order, in this kind of question, this kind of based questions. Okay, you just go through the PYQs of JEE NEET, you will get some clarity over these reactions and what type of questions they are asking. Okay, anyways, we will be having a separate numerical session on all these topics once after finishing this chapter. Okay, hope this is clear. So stay connected with this NEET World channel, and if you require any help from us, you can write in the chat box. We will going to cover those topics, and to be in contact with us, just join our Telegram group from the link which is given in the description here. Okay, just open your description box. There you will be seeing one Telegram group channel. You can join that, and you can clear your doubts there. You can post your doubts there. And you can interact with teachers. Okay, so thank you. Stay connected with us.